last problem we want to kind of go over when talking about compound inequalities is one where we have to model a real-life problem. It says here the park is 1.5 miles away from your house, and the mall is 2 1/4 miles from your house. Find the minimum distance between the park and the mall. Okay, well, first of all, if I live right here, this is my house, and let's say I want to go to the park, which is 1 1/2 miles away. So here's the park. And then I wanted to go to the mall. Now the mall is 2 1/4 miles away. Okay. And here's the mall. So we know that from my house to the park, it's 1.5 miles. But if I went from my house to the mall, it's 2 1/4 miles. Now we're going with the assumption that this is a straight path. Okay. And what we want to know is the minimum distance between the park and the mall. What is the closest they can be? Well, the closest they can be is if this lied in a straight path. So all I would have to do is take our total difference of 2 1/4 and subtract the distance from the house to the park, which is 1 1/2. This is our total difference. I just want to know this. I'm going to take our total difference minus our 1 1/2. So if we want to write these with a common denominator, that would be 2/4. But then we still can't subtract because, well, we can't go 1 minus 2 because there's a whole numbers out front. So I'm going to borrow a 1 from the 2. When I borrow 1, I actually borrow 4 little pieces. So I'll rewrite this. This is 1 5/4 minus 1 2/4. I just had to use the idea of borrowing with fractions. I cannot go 1 minus 2, so I borrow 1 from the 2, but remember when we're borrowing a 1, we're actually borrowing 4 out of 4. I had 1, I'm adding 4 more, that's where the 5/4 comes from. So if you subtract, our 1's cancel, 5 minus 2 is 3. So the minimum distance is 3/4 of a mile. How about the maximum distance? Well, for that I'm going to use the idea of some circles here. We went with the assumption to start that they lie on a straight line. But remember, if I'm walking from my house to the park, I could walk in this direction. Here's the park, and it's a total of 1 1/2 miles away. Well, what if the mall is in the exact opposite direction? The mall's over here, and it's 2 1/4 miles from my house. Oops, actually I wrote this wrong, I apologize. Let me bring out my other circle here. It's not, I can't put it on this circle because it's not the same distance, but I could put it out here. And this is a total of 2 1/4 miles. Okay, because again, it doesn't tell us the direction that we're going in. So let's just say if I go this way, I go 1 1/2 miles to the park. If I go from my house this direction, it's going to get me 2 1/4 miles to the mall. So if we think of it as being on a straight line, just in opposite directions, the maximum distance in this case is we're just going to take 1 1/2 miles and add 2 1/4 miles. Okay, if they're in opposite directions. Again, that's like saying 1 2/4 for a common denominator plus 2 1/4, and that's a total of 3 3/4. So our minimum distance is right here, 3/4 of a mile. Our maximum distance, is going to be 3 3/4 of a mile. Part C here then wants us to write an inequality that describes the possible distances D between the park and the mall. Well, we decided that it can be no less than 3/4 of a mile. That's the smallest distance it can be. But we also said our maximum distance is 3 3/4. So hopefully it makes sense that the distances D here have to fall in between these two. They're not going to be any less than 3/4 or any bigger than 3 3/4. So We're talking about an and statement here. 3/4 is going to be less than or equal to, because it can be equal to, our distance, which is less than or equal to 3 3/4. So this inequality represents all the possible distances that the park and the mall could be away from each other.